Assalamu alaikum warahmatullah. Hello friends, in this video we shall see the simulation for the diffusion in the networks that we studied in the last video. So over here there are two ways to simulate diffusion. First of all, let's create a network. So I generate stylized network, and I create a scale-free network with 100 nodes, right? And all the default settings. Create. So we have this network now, right? And we can visualize this. So this is the network with 100 nodes which is created. So let's first see how do we run the simulation. So one way to execute a simulation means we'll see the diffusion over time in a network, right? So is to go here and then do the micro simulation. So select a node set. So we selected agent, and this is the network which we are going to run with, and select the nodes that will act as the source for your simulation. So which node will start the diffusion? So for example, we can start the diffusion with node number 6, node number 14. Next, and it says diffusion of ideas, diffusion of disease, diffusion of dispersion of money, and adoption of technology. So there are four different sets of four different simulations which are available. Diffusion of ideas has to be different from diffusion of disease, has to be different from diffusion of money, has to be different from adoption of technology. So why there are four different? Why not one? So we'll see. There is a documentation of ORA Lite which actually mentions why these are, what are the specific configurations of these four uh, simulations. And there is the resistance. A high resistance decreases the probability of node accepting transmission. So the resistance by default is 0, but we can set it to any value between 0 and 1. So this is the resistance. It means for any diffusion instance, what is the probability that the diffusion will not take place. So if, say, it is diffusion of money, which is more relevant for us in the course we are studying. So for any transfer of money between one node to another node, uh, it will be probabilistic. So 70% of the time the transfer will take place, but 30% of the time the transfer will not take place. So this is something we can set by default. So I set it to say 0.1. And number of periods to run. So uh, number of periods to run. So for how many periods we want to run this simulation. So let's say it is 1, and it jumping by the number of 5. So I run it for 11 periods. And condition number, I have to see what this condition number is. So let's keep it at 1 by default, and generate micro simulation matrix. So as soon as I did it, I did not see anything over here in terms of visualization, but I see that there is another network has been created. A meta network has been created, and the icon of this meta network is different from the meta network that we generally see. So it's a sort of a dynamic meta network, right? So let's expand it. And we see there are 11 different, 1 2 3 4 5 6. So these are the instances numbers. So you see over here, so this is March 31, this, which is the date tomorrow. This is, so for every day, so it's assuming that simulation is run every day, right? So these are the dates. So every day the transfer of money takes place, right? And you see all the rest of the settings are almost same. There is no change in the density. So the network itself is a static, but if we consider the money itself as a component of a network, so money, right? So if you see money, we have two nodes, 0 and 1. Either money is there or money is not there. So it is configured as a node set, right? So for every network, for example, the very first network over here, you see we have agents, we have money as an agent set, and we have graph, we have utilized network, and we have simulation network. So for example, let's visualize this. And now you see there are these are the nodes, and if we key away this, so you see this is the original network, right? Original graph. And if I click this, now you see this is the this is the network on 31st of March. So you see there are, since there were uh, two nodes which we selected um, for the distribution of money. If you recall, there were two nets. So 0 and 1 are the node numbers. It's not money is there or money is not there. So these are the node numbers. So these two nodes, agent number 6 and agent number 14, were acting as the source of money. So you see at the first instance, they only have the money, right? So this is the 31st March. So they have the money. They are linked with the money. But if you, for example, you close it and you, let's visualize the second one, right? So which is on 1st April. So what happens on 1st April? So on 1st April, if we just keep this simulated links, so you see now the money is with agent number 34, and over here the money is with agent number 14. So money has changed hands after one day because the diffusion takes place. If you want to see the utilized network, then this is the utilized network, right? So what actually happened, we started with agent number 6, right? And let's see the simulation network as well. So we started with agent number 6, right? And it went to its very next agent, which is, let's stop it so that we can see it more clearly. So it went to agent number 34 because agent number 6 is connected to agent number 34. So it has passed on to the next agent. Similarly over here, it was with agent number 14 and it is still with agent number 14. It's not going to diffuse because, why? Because this agent is isolated. It is not connected to any other agent. And let's see the graph only. So what is the graph? If I want to spot the agent number 6, so you see actually this is the agent number 6 and this is the way the agent number 34 was connected directly. So that's why the money passed on to agent number 34. The money could have passed on to other links, right? But since it is probabilistic, so it's just like tossing a coin. So all the nodes were candidate, all the connected nodes were candidate to which the money could have passed on. So then according to the random number, agent number 34 was selected, and according to the resistance, the money passed on to agent number 34. So this way it simulates and it takes place. So let's now move on to the last slide, the last instance, which is on 10th April. So what happens after 10 days of diffusion? Visualize. So see now, let's switch off it. So where it started with agent number 6, right? So this is the utilized network. It went to agent number 34, then 83, probably, maybe, and it is now with agent number 12, right? So this is the utilized network. It means this network has been tried by the system for the random flow of this. And since this is a disconnected component, so maybe the money will keep diffusing over here. It will not go beyond out of this. And if you go here, it is still with agent number 14 because this was an isolated agent. So it couldn't pass on the money to others. So this way we can actually view and keep in mind that this is not deterministic. I mean, this time it was from agent number 6 to it was agent number 34. Next time we run the simulation, it can be not agent number 34 but maybe some other agent. So for example, if we just see graph only and we see where is agent number 6 where we started from. So agent number 6, there are ways to find agent tools, node selector. So I want agent number 6 probably. Why not you are showing me? Use the node selector to manipulate aspects of nodes in a visualizer, region number 6. I don't know, it's not showing. Anyway, so if we can spot agent number 6, we can see that the money could have gone to other agents as well, because agent number 6 is not only connected to agent number 34. So if we next time we run the simulation, we can have different results, right? So and this way we can actually I just wanted to show you this simulation part, and of course some of the things are very much clear that if simulation starts from some agent who is disconnected from the network, then of course course the diffusion is not going to take place. But if you start with some agent who is connected with the larger node set, then eventually the diffusion takes place. So that's it. In the next video, we shall see running the diffusion from the visualizer itself. Okay, now we see some features which are available over here as a dynamic network. So if we visualize this this meta network, which is a dynamic network, visualize, we see that we have not only we have the network window, but we have another window which is network over time, right? So which is a sort of a dynamic network. So if you recall earlier, I mentioned that diffusion is not a dynamic network phenomena, but over here it is showing it's a sort of a network over time dynamic network phenomena. So from the perspective of the network itself, the agents, the node sets, it is not a dynamic network because the network is not changing. But if we take the money itself as a node, then of course the network with money, the network of people with money is going to be evolved over time. So that's a sort of dynamic network. So we don't need a binary answer. So yes, it is a dynamic network in the sense that the money is diffusing, but so including the money in the network as an agent, yes, it's a dynamic network, but just the network itself, it's a static. The structure of the network is a static. Anyway, so I set it to auto layout, auto zoom, and it will run for 11 I mean, so these are the 11 timestamps, right, from 31st March onwards. So let's do it now. Where it was, it went away. uh, okay, why the window is not visible, I'm not sure. Okay, so maybe view. Okay, I'm not sure why it got hide, so I have to call it again. Right, this software is not very perfect, right? So we are here. Okay, auto zoom, auto select, and then now I say play. So every 1.5 seconds it is showing us how it is. Okay friends, I'm sorry, it disconnected the charging of the laptop. It was not connected to charger. So as you can see, it's not very helpful, this kind of visualization, because neither there is any data that's being generated that we can use for analysis over here, nor the visualization is very appealing. So anyway, it was just to show you the feature which is available in the system. Now, okay friends, so I now just remove this dynamic meta network, right? And this is the original network. I visualize it, and now I want to run the same simulation from here, right, in the visualization. So we have over here tools, and here is a micro simulation, almost the same. Select a node set, agent, and we have to select the scale free network as well. Next, so the source agents, again node number 6, and I don't exactly recall, it was node number 14 if I recall correctly. And I say next, again the resistance, and increase number. So this simulation is visually more appealing, right? So but I don't because this increasing the node size won't work very good. So I just say there are additional tools, rapid simulation matrix creation. I just don't use it. I say okay, play. You see here it's starting and how it is spreading, right? And it is a diffusion of ideas. So this is the largest component, and you see node number 14, agent 14 was actually isolate, so it couldn't split, but the rest of the nodes have split all the ideas. So the color blue and green have some meaning. Now let's cancel it, reset all the nodes and links. Let's go again, action, sorry, it was tools, micro simulation, agent, scale free network, and recall it was agent number 6 and agent number 14. Next, so now dispersion of money. So what's one of the key difference between the diffusion of ideas and the dispersion, diffusion of disease, and the dispersion of money, is that ideas, when they get to the other node, they also remain with the originating node. But when money goes to the other node, the originating node no longer has it. So money actually travels, whereas the ideas spread. Similarly, disease, when one node has passed on the disease to other, then that node becomes immune. It cannot, the disease cannot come back to the same node, but the money can come back to the same node. So there are few differences in terms of how the flows are there, which I should share with you, because these are there in the documentation of the ORA Lite. So anyway, now let's again, there is no time setting over here that we can slow down or we can, so let's do one by one, maybe one. So this is step number one, right? When you see, let's it started with agent number 6. Second step, agent number 6, its passed, goes to agent number 79. Now see the simulation. Earlier it went to agent number 34. Now it is in the first step, it went to agent number 79. So this is how the probabilistic simulations work. And then it went to many other nodes. Again, I'm sorry, it is a diffusion of ideas. We have to keep a diffusion of money. I'm sorry, it couldn't go to all the nodes altogether. So reset, tools, micro simulation, agent, node set, next. So we need to keep it to agent number 6 and agent number 14. Next, diffusion of money, resistance, let's say 0.1, and start. So this is node number 6 starting. The second step, it attempted, but probably didn't went anywhere. Any other green node, can you see? Yes. So it went directly to node number 52, right? So as you noted that node number 52 has direct connection with node number 6. If you just see, right, it has a direct connection with node number 6. That's why. So it's probabilistic. It's now node number 43 or 35, just like the last one, last simulation that we saw. It's node number. So every time you run, there can be a different result. So let's play it all together. So now this play, it works, right? So this is, so at least visually this simulation is more appealing. You see how long it takes to pass on through the entire component. Of course, it can only pass on to this component, not the disconnected nodes or components. Right, so I stop it over here, maybe this, and I just export it to Aura multiple meta networks. I want export to Aura dynamic, so it will automatically export it as a dynamic meta network. So I close it. I close this visualization well, and you see again I have a micro simulation dynamic network over here, and how many steps it has run. You can see over here 7 April 7, so it has run almost up to April 27, so almost 27 or 28 steps it has run. If we recall here, visualize, then again we can see this simulation from here, then as we earlier saw, but this is not very much appealing. So these are some of the features which are available for simulation in ORA Lite, but again, I would say this is not a good tool for simulations. I am myself into simulations very much as far as research is concerned. So my main research area nowadays is agent-based simulations. So we have another tool which we use for simulations. That's very great tool in which we see the diffusions as well with so many parameters. So now let me show you some more features which we should be familiar with in terms of some of the things. So for example, visualize can have a sphere of influence. We can see the sphere of influence of any node up to a certain radius. So for example, if I call it and sphere of influence radius 1, it means a sort of a ego network, everybody with one step away from a particular node. So I want to see the sphere of influence of node number 6, for example, right? And there are certain other settings which I keep as they are. Use outlinks to determine adjacency, use inlinks, so both, right? Not and auto center maybe, and auto zoom. Let's keep it to auto zoom. Run. What happens, right? So you see, it has kept agent number 6 at the center as an ego, and it has mapped all the nodes which are connected. And you can see there are 22 nodes which are connected with agent number 6, and there are 81 links in total. Why not 22 links? Because many nodes are connected with one another, and there are bi-directional links as well. So for example, if you see this link, this is from 48 to 23 and from 28 to 43 both, right? So these are inwards and outwards both. So that's why the number of links are 81. So let's close it. So this is one important thing that which we can just extract the ego network and see who is connected to whom. And then one more thing, again we can select more than one nodes over here as well. So maybe agent number 3 as well, run. Now I have both nodes connected to shown on the screen, a total of 30 nodes and a total of 124 links over here. Let's close it. One more thing which is very good to see is again the pathfinder. So if I go to the pathfinder and say, okay, I want to see the path of node number 6 to node number 38, if any. If they are disconnected, it will show there. So use links direction, use links weight, right? So filter across links. Probably this means that it will not take care of the direction of the links, but I'm not sure. Let's run it. So you see now we have from node number 6 to node number 38, how many paths are there? So it's not very visually very much appealing. I think there is a way in which it can be more use in links and out links, in links link direction. Maybe select a shortest path tolerance. Not sure. Run. See this. It's same. Let's run with this one. See this. Okay. Okay. So let's keep it to 0. Advanced options. No. Run. Okay. So it shows us actually all the possible paths which can lead us to node number 38 between 6 and 38. So you can see from 6 we can go to 13 and 38. From 6 we can go to 37 and 38, and from 6 we can go to 48 and 38. And these are the shortest path geodesics. If we allow some more flexibility, one means that it can probably add one more node. Then it will not be a geodesic, but it can still be a path. So we can just change the settings on the previous screen. So this way we can see that there are how many geodesics, possible geodesics, without taking care of the direction. 1, 2, 3. There are 3 possible geodesics. Now let's run this with the direction. Let's keep out the filter across links, filter cross links, and then run. What happens? So node number 6 to, again we have same 3 paths, 1, 2, and 3, right? So I'm not sure what does it filter actually works, but directionally, since all the links are bi-directional, it means they are in and out as well, so we can use any of them. So that was another feature which I want you people to be used to. So thank you, and I think that's sufficient for the lab. And now probably this will be uploaded on LMS along with some other material. So take care. Thank you.